folks, welcome back. And today we're continuing our discussion on nomenclature. We've finished up ionic compounds and we're moving on to covalent compounds now. Now remember, covalent compounds are made from non-metal elements only. So let's take a look at our periodic table. We're going to draw in our border again. Doesn't that begin beneath boron? And it's a little staircase over here. And so it contains these elements over here and hydrogen, those non-metals, bonded to each other. You would think there wouldn't be very many covalent compounds because there aren't a whole lot of nonmetals, but if you thought that, you would be wrong. Now just to note, there are many more metallic elements, as we just saw, than nonmetallic elements. Thus one would think that there are more ionic compounds than covalent. This is far from true. There are many more covalent compounds than ionic. Now because of the large number of covalent compounds and the complexity of many what we call organic compounds, those that contain the element carbon, you will only be required to name and write formulas for binary covalent compounds for right now. Now, of course, those will only have 2 elements in them, so that will make your life considerably easier. Now, the way we name them is pretty easy. We simply name the first element and then the second element, and we end it with "ide." It gets a little bit more complicated than that, but not much. So the first element in HCl is hydrogen, so we'd simply say hydrogen, and the second element's chlorine, but we would end it with "ide," so we'd say that was hydrogen chloride. This compound here, H to Br, would obviously be hydrogen, and Br is bromine, but we'd change the ending to "ide" and say hydrogen bromide. Now that's way too easy. What if I had this situation? I have 1, 2, 3, 4, 5 different N to O compounds. If I use the naming system above by naming the first element and then the second element, naming it and changing its ending to "ide, wouldn't these all be nitrogen oxide, nitrogen oxide, nitrogen oxide, nitrogen oxide, and nitrogen oxide? Can they all have the same name? No, they can't. So there has to be a little bit more to it than this or than that. So what you guys are going to have to do is memorize the following prefixes. You should know that the prefix mono means 1, di means 2, tri means 3, tetra 4, penta of course is 5, hexa is 6, hepta 7, octa 8, nona 9, and deca means 10. Now, with those prefixes in mind, let's go back to those nitrogen and oxygen compounds that we just left behind, and let's go ahead and erase these stray marks here at the bottom of the page. And let's use this naming system here. Okay, what we do is we use prefixes to describe how many of each atom are present in the compound. So, NO would be mono, nitrogen, mono, oxide. Now we're not going to put 2 O's in a row because it would sound like monoxide, so we just use 1. So we'd say mononitrogen, monoxide. Now fortunately the prefix mono is optional, so we can leave it off. So the first compound we could call nitrogen oxide and be just fine. What would I call this second compound? Well, let's go ahead and start with 1 nitrogen. We'll leave the prefix mono off this time. That's optional. I could say nitrogen. And now the prefix for 2, do you remember what that was? Correct, it's di. So I'd say dioxide. So NO2 is nitrogen dioxide. What would N2O3 be? Well, that shouldn't be too hard. Let's do that one up here. We have 2 nitrogens. The prefix for 2 is di, and then we'd say the first element. Don't change the end of its name when it's the first element. And then we'd use the prefix for 3, which is tri, and then we'd name the second element but change its ending to ide, oxide. So this third one is dinitrogen trioxide. The fourth one would be dinitrogen tetraoxide, And the fifth one would be dinitrogen pentaoxide. And that's all we do to name binary covalent compounds. So why don't you try a couple? Why don't you try to name all of these covalent compounds in example 18 by using the prefixes up above. So go ahead and pause the video. Do your best. If you make a mistake, don't worry, you can fix it in just a minute. Do your best and then come back to the video, press play, and see how you did. Okay? See you in a second. Alright, welcome back, kiddos. So the first one, we have one carbon and one oxygen. So we have the prefix mono. Remember, the prefix mono, kiddos, is always an option. You don't have to use it. Sometimes we do, sometimes we don't. You don't have to. So the first compound you could call carbon, or if you wanted to, you could call it monocarbon, and then you could say oxide. Or if you wanted, you could say monoxide. So this happens to be commonly called carbon monoxide. And now you know why. There's one carbon, and the monoxide means there is one oxygen. Okay? How about the second one, CO2? Carbon, that means there's one of them, and now we have two oxygens, so we have dioxide. And you've all heard of carbon dioxide, haven't you? Okay, P2O5. So we have diphosphorus. Remember, don't change the ending of the first element, diphosphorus, and then 5 pentaoxide. Now that A and penta could be dropped if you wanted to. Sometimes it's left in, sometimes we take it out. I am easy either way, so you call it pentoxide or pentaoxide. SO2. So we have one sulfur, so we can just say the word sulfur, and two oxygens, so we have dioxide. And then SO3 would be sulfur trioxide. H2O, well, that's a pretty common one, but let's go ahead and give it its chemical name. There are two hydrogens, so we'd say dihydrogen. And then we could just say oxide, or if you wanted to, you could say dihydrogen monoxide. Your choice. Now, of course, the common name for this is water. And even the most hardcore chemist will call H2O water. It's very unusual that one will call it dihydrogen oxide. So we can just get away with calling that water. And I expect you to call it water. Okay, P4O10. So the prefix 4 up here is tetra. So we have tetra phosphorus. And then 10. So 10 over here is deca oxide. And once again, if you wanted to leave the A out of deca and just call it decoxide, I would have no problem with that. NH3. NH3. So there's one nitrogen, so we could use the prefix mono if we wanted to, but I'm going to leave it off, so we're just going to say nitrogen, and then 3. Tri, remember the second element has to end in "ide", so trihydride. Nitrogen trihydride. Now the common name for that is ammonia. And that's another one. A hardcore chemist will not call NH3 nitrogen trihydride. They will almost always refer to it as ammonia. So I expect you to use the common name for NH3 as well. CH4 would be carbon. Now we have 4 hydrogens, so that would be tetrahydride. So carbon tetrahydride. Now the common name for that is methane. So I expect you to use the common name for CH4 and not the technical name for it. Alright, so that was some good practice in class. We're going to do some more of these. As soon as you notice that we have a non-metal to a non-metal, okay, you switch to the covalent naming system and you use prefixes. Okay, you should think that these are easier because they are. All right, see you soon. Bye-bye.